Welcome. And today we're going to talk about the equations of motion that come into both physics and maths. So what do we mean by the equations of motion? Well, firstly, we need to be a little bit more specific and remind ourselves that these are called the equations of uniformly accelerated motion. That means that these equations are only valid for an object where the acceleration stays the same or is constant. So you can use it for parts of a journey, but if an object, for example, accelerates, then travels at a steady speed and then slows down again, it's only valid for parts of that journey. You can't use it for the whole journey. So any section of the journey where the velocity time graph is a straight line would mean that these equations are usable. So let's look at them. Okay, now in the equations we have various terms that we use. We always use u for the initial velocity. We use v for the final velocity, and the reason we use those is because alphabetically v comes later than u, so we know it's the later velocity. Acceleration is always a small a, displacement a small s. The time taken, and by the time taken we mean the time taken to go from the initial velocity u to the final velocity v. And the displacement mentioned here, s, is the displacement during the time that it was going from u to v. So let's have a look at the four equations of motion then. V equals u plus at. So we have an equation for acceleration that says that a is v minus u over t. That's the change in velocity divided by how long that took. So this is just a rearrangement of that acceleration equation. Its purpose for us, from our point of view, is it allows us to work on those four things without needing to know the displacement s. So if you don't know the displacement and you're wanting to know one of these four things, v, u, a, or t, then this is the equation to be using. V squared equals u squared plus 2as. So it's possible to do a bit of maths and work out that this will be true. And its purpose, as you can see, is to allow us to find one of these things when we don't know the time involved in the motion. So we need to find v or u or a or s, but we don't know t. This is the correct equation to use. S equals ut plus a half at squared. So again, the purpose of this one is where we don't know the final velocity v. So if we're trying to find s or u or the time or the acceleration, but we don't know the final velocity, then this would be the appropriate equation to use. S equals a half upon u plus v times t. So if you think about a half of u plus v, that's the average velocity, like u plus v over 2. It's the sum of the two velocities and divide by 2. You're finding in that bracket, multiplied by half, you're finding the average velocity. So what this equation is basically saying is that the total displacement can be found if you multiply the average velocity by the time of the motion. And its unique selling point is that you don't need to know the acceleration. So if you want to find s or u or v or t and you don't know a, this is the correct equation to use. So what happens with these is that there are various situations where we have uniform acceleration. In the motion of a car, where they tell you the acceleration is uniform, anything falling under gravity will have a uniform acceleration of g, and g we either take to be a round number of 10 or a value of 9.81. So falling objects above the Earth, or objects that are free to move above the Earth, will have vertical accelerations that are constant. And so any motion that's described as having a constant acceleration, and any motion where it's implied. So you could imply that it's uniform motion if someone drops a brick out of a window. So these are the examples of where these can be used. And again, the idea is very much that they each have a little purpose. So if we go to the next slide here, we've got the idea of a summary. So if we don't know or need S, but we're trying to find one of those other things, we use the first equation. Second equation is where we don't know T, but we need to know something in the blue. Third equation is where we don't know the final velocity. Fourth equation is where we don't know the acceleration. So I hope that helps you to pick out an appropriate equation when you're asked to do a uniform acceleration question. Okay, thanks for watching.